And we're back. I made one or two changes while I was waiting for the thing to save. I just put everything in one folder now, so I resaved that the file we were working on in another location. Now, something I've added to this location is this little shortcut. Now, it's a shortcut to the executable for FLAC 3D version 6. So one of the important things here you'll notice is it says start in and there's nothing there. So wherever you run this shortcut, it will run in that particular location. So I'm going to do that now because one of the next things I need to do is get to the help file. Yeah, you'll see I'm not up to date, but that's fine. Okay, so help file, I'll just press F1. Now, manuals used to be in PDF format, now they're in CHM format, which is not as accessible or useful or convenient. Um, I think they used a previous version of the CHM viewer when Windows was friendlier that allowed you to do searches inside pages, etc., but this one doesn't. So fortunately, it's a bit of a step back in terms of the manual. And of course, you have to develop a whole new workflow in terms of how you look things up. The search, unfortunately, is not very useful in the CHM format. Um, the reason I'm bringing up the help is because the next thing I want to do, of course, is to generate the geometry. Um, and I'm going to just copy some things here. We only probably need one example. I'm going to fish define a new routine, and I'm going to call it build model, and then just out of habit, make sure that it runs as well, because I often forget those things. And then you'll see I always put these little comment bars and empty lines. It's just to separate the thing up so that you can so that it's more convenient to use. And of course, I've cancelled what I copied, or overwritten what I copied, so I'll go back there, copy it again. So you'll see here the command I'm going to end up using, zone create brick size, blah blah blah. Excuse me. Zone create brick size, and these three variables then refer to the number of zones on those axes, and we'll see what those axes actually are. The ratio is well, you can grade the size of the mesh by simply applying a ratio. So one block will be 1.1 times the size of the one next to it, etc., etc. So I'm going to go to the help file to actually look at the reference, and I haven't done this before, or I've done this a while ago, so this could take a while. You can also use this new building blocks feature. I haven't used it before, so I'm not going to debut it here. I'm going to go with, okay, so it's zone create, so it'll be under here. So this is my workflow for the help file these days. So look at what I'm trying to do. So it's zone create. So it'll be under FLAC 3D elements zone. And what I'll be doing is looking at commands, and it's zone create. Zone create, and here are some little graphics which show us what's going on. They're not very useful graphics though. We'll have to go to the particular one that we're interested in. So zone brick, and hopefully there's a link. Are links, there we go, thumbnails of primitives are links to enlargements, indicate the shape's reference points. Not in a format I can use, of course. Okay, I can use control click to actually zoom in and out, control mouse wheel to zoom in and out, so at least that still works. So we're developing, or we're going to create a series of and these are called well, this brick shape is basically a tetrahedra, so it's a six-sided, regular-sided thing. It doesn't have to be rectangular or with parallel sides. You can specify those points anywhere you like. But if you don't have a planar side, you're going to have some issues. Okay, so one of the things you may notice, of course, is that you only need 3 points to fully define this thing. You only need, if it's going to be completely rectilinear, you're only going to need 3 points to actually specify it, or 4 points, sorry. So how are these bricks actually going to work? Let's think about that and look at our sketch again. So we want to have a constant zone size within the pillar itself. As I mentioned earlier, there's two ways of approaching this. You can actually model the whole excavation sequence, or you can model pillars and then develop a kind of pillar formula based on that. So I'm going to go with the latter option here, because if I were to model the full excavation sequence, I would need uh, the same size elements or same size zones throughout the cross section of the model. Now that's quite a big model then, whereas if I only have to mesh the pillar, then I have a much smaller model and everything is a bit more manageable. So I'm going to take the latter option, because actually that choice affects the geometry of the model quite fundamentally, and allows me to take a number of shortcuts as I go forward from here. So we're going to build the model. We're going to build the model in 3 pieces. We're going to do, excuse me, we're going to do the pillar itself, the hanging wall and the footwall. And the hanging wall and footwall allows us to actually, sorry, roof and floor, coal parlance, allows us to grade the mesh away from this corner and this corner and this corner, which is the center of the pillar. As I may have mentioned during the lecture component, the contact, we're going to connect the pillar to its roof and floor by using contacts, right? So you don't actually need coincident nodes on the roof and floor contacts then. As I mentioned earlier, while we were doing this particular model, is that we don't need to worry about the roof and floor properties. A fundamental component of a pillar's functioning is how lateral forces end up being transferred into the pillar. But if we don't expect any failure in the roof and floor, we don't have to model that as strain softening. We can just model it as elastic. So that's what I'm going to do. I'm going to have one block here, constant size zones, and I'm going to have another block here, which is graded away from this corner, which is that corner, and another one which is graded away from this corner, which is that corner. And let's see how it works. It might give us problems. The interfaces might complain or not work very well, but we'll see as we go along. I'm trying. This is my first stab at the thing. If it doesn't work, we'll try something else. All right. So let me relabel things here so it all makes sense. I'm going to create one block of the pillar. I'm going to create one block of the roof, and then later on of the floor. Okay, so for this you'll see I've used tokens here, which are x1, y1, etc. Okay, these are specific to another model. So one of the things I need to decide on, of course, is what my zone size is going to be. So that's one of the first I'll do. Then I'll say, sorry, zone size is, let's see, we said 4 meters high. Let's say we want 10 zones from roof to floor. We can say then, okay, roof to floor, mining height. I can actually explicitly do this as well. So I can say that divided by 10, and that's going to be my zone size. Just ignore all that stuff up there. I'll go back and delete that later. I'm going to need some of that actually to do the grading, but for now, let's just focus on this part down here. So my zone size is that. So the number of zones, sorry, headset failure. Number of zones in X is going to be, and I've got XP there, variable. So to be complete, I will say xp minus x0, which is correct. Even yeah, or let me not get too fancy actually. You could end up being too clever for your own good here. So I'm just going to say, I know that the center of my model is at 0, so I'm going to say nzx, number of zones, is xp divided by the zone size. Great, done. No, not done, because what this is going to do is it's going to say xp, which is say 15 meters, or 7.5 meters, and then it's going to divide it by 0.25, and of course I'm going to get a floating point number out of there. I can't put floating point numbers when I'm specifying integers. So we use one of the conversion functions, int, which converts floating point numbers to integers. We'll do it with strings as well, actually. So I know I'm going to get an integer out of there. And I do the same for y. yp, I want my zone sizes the same in x, y, and z. And then nz, it's a bit different this time because this is going to be mining height, I think. Yeah, mining height over zone size. Was it seam height? What did I have in the end? I left it as mh. Okay, good. Alright, so now I can generate my block quite easily. I just need to keep in mind now, based on this thing, where everything is. So P0 is, say, at the center of my model. So I'm going to have that as, you know what, let me actually specify this now. x0 equals 0, y0 equals 0, and to be perfectly correct, I'll put that there. And there. Okay. So, right, point 0 will be x0, y0, and z0 as well, actually. x0, y0, z0. Sorry, the ratio here will be 1, 1, 1, because everything is the same size. It's a uniform block. Point 1. Point 1 here will be xp, y0, z0, xp, y0, z0, sorry, not z0, it's going to be z floor, isn't it? Z floor. Point 2 is here, so that's x0, xp, x0, yp, still z floor, and then the third point is up here, so it's x0, y0, z roof. Group, we can assign a group now if we like, and why not? I'm going to call this group, and we can set this elsewhere as well. In fact, I can set it here where I set up my variables. I can say goal group equals goal, and then I can just put that in, and I could say default slot. You know what, I'm actually going to leave the slot out so that it automatically applies it as the default. Alright, now that's our first block created. Our next block is a bit more interesting. because we're going to apply a ratio. Okay, I'm going to have to stop again just because these files end up being quite enormous. So I'll be back in a second.